Cardioids and lemmasons both have the same equation. They both have k, then either a plus or a minus, never both, but either a plus or a minus, and then either c cosine theta or c sine theta. And so what makes a cardioid, specifically a cardioid, is the k number and the c number. If you take the absolute value, you get the same answer. So the number itself is the same, even if there's a plus or a minus difference. Whereas with lemmason, you have two different values, and that changes the graph. But the nice thing about these is you don't have to memorize a bunch of little individual rules. All we're going to do is take and plug in 4 values into the equation. We're going to plug in 0, pi over 2, or 90 degrees, pi, or 180 degrees, and 3 pi over 2, or 270 degrees. And then once we have those values, you can kind of see it over here, we're going to plot those 4 points. So this would be a case where they plotted those 4 points. And then you can see in the little direction here, we connect them with a smooth curve, except for the one sharp corner, and that sharp corner will always occur right at the center at the origin. So if we had plotted these 4 points, to draw them, you don't need to be perfect, but we don't want to have something really sharp and ugly like that. It should go in a big, smooth, wide curve, and smooth at the other end, smooth at that dot, and just a sharp corner there near 0. Let's try one here. So, again, I'm going to plug in 4 angles. I'm going to plug in 0, 90, 180, and 270. And so then when I plug those in, my equation becomes 3 plus 3 times the cosine of 0 degrees, and 3 plus 3 times the cosine of 90 degrees, and 3 plus 3 times the cosine of 180 degrees, and 3 plus 3 times the cosine of 270 degrees. And the nice thing about these 4 numbers is they're nice, easy unit circle values. They're all going to be 0 or 1 or negative 1. We just have to be careful about which. In the first one here, I'm going to have 3 plus 3 times, and the cosine of 0 is positive 1. So it's really 3 plus 3, because 3 times 1 is 3. So, not 3. So that'll be 6. So what that means is when I'm rotating 0, I'm really plotting the point 6, 0 degrees in polar. So if I rotate 0 degrees, I'm still facing the right, and then I need to go out 1, 2, 3, 4, 5, 6 positive steps, or 6 steps in the positive direction. Then we move to the next one. 3 plus 3 cosine 90 will be 3 plus 3 times, but the cosine of 90 on the unit circle is 0. So this 3 times 0 becomes 0. This is really 3 plus 0, which is 3. And so when I rotate and face 90 degrees straight up, I'm going to walk forward 1, 2, 3 steps. And then next I look at 3 plus 3 times the cosine of 180. That'll be 3 plus 3 times negative 1, because the cosine of 80 is negative 1. Well, that's really 3 minus 3, which is 0. So when I'm facing 180, I don't walk any steps at all. And then last but not least, I have 3 plus 3 times the cosine of 270, but the cosine of 270 is 0 again. So I really have 3 plus 0, which is 3, but that's when I'm facing straight down, when I'm facing 270 degrees, so I walk forward 3 steps. There are my points. Do not connect the dots with straight lines. This is not going to be a triangle. What I need to do, and this is tricky, it takes a little practice, but I need to start, I usually start at that point. That's where my sharp point's going to be. I need to sweep way wide. In fact, that might not even be wide enough. Way wide, so when I get to the bottom, that's relatively smooth. That's not too bad. It's hard to draw them, but as long as you have kind of nice smooth curves, you should be fine. And that would be our graph. Let's do one more. This time we have a minus in there, and we also have a sign. So let's see what happens. Again, I'm plugging in 0. I'm plugging in 90. I'm plugging in 180. Plugging in 270. Well, when I take 2 minus 2 sine 0, I end up with 2 minus 2, and the sine of 0 is 0. So it's really 2 minus nothing, so it's at 2. So when I face 0 degrees, I'm going to go out 2 steps. Then I'll do 2 minus 2 sine 90. Well, the sine of 90 is 1. So now this is going to be 2 minus 2 times 1. Well, 2 times 1 is 2, and 2 minus 2 gives me 0. So this time, when I'm facing 90, that's where I get my 0 point. Then next, I'll have 2 minus 2 sine 180. Well, 2 minus 2 sine 180, the sine of 180 is again 0 degrees. So this is really 2 minus 2 times 0, which is 2 minus 0, which is just 2. So when I'm facing 180 degrees, I need to go 2 steps forward. And then last but not least, I'll have 2 minus 2 sine of 270. And the sine of 270 is negative 1. So I really have minus, then 2 multiplied by a negative 1. And then what happens is we have this negative and the negative 1 from multiplying. So you end up with 2 plus 2, which is 4. So when I'm facing straight down at 270, I actually need to walk out 4 steps. Oof. Yeah, and that should really be a better point there. There. So, a couple other things I just want to point out. Plotting the points works great to graph them. There are some other things that also always happen too. If you look at the numbers going on, these are more things kind of to notice. But if you look at the points we plot, we always have a 0 point. But then there are always going to be 2 that are kind of the same distance apart. And then there's going to be 1 point that's furthest away. You can kind of look at the equation to help you figure out what's going on here. If you have a minus with a sign, that furthest away point is going to be down. That's why our cardioid opened down here. And that distance away is always going to be those 2 numbers added together. So this furthest point away is down at 4. And then the 2 points to the side, and then always the point, whichever point is furthest away, the other one in that direction is at 0. These 2 points on the side, it is not a coincidence that they are 2 away. That is matching the 2 that's there. So that's kind of another little trick you can use to confirm. And you actually can even sketch the graph that way if you're careful. So let me just draw a quick sketch of one here to show you what I mean. Let's say I was going to do, well, maybe I'll do 2 plus 2 cosine, or I'll do the same thing, but I'll do sine. So instead of 2 minus 2 sine theta, I'll do 2 plus 2 sine theta. What you can kind of do is say, well, since this is a plus with sine, my furthest away point is going to be up 4 away. And then the other point in the y direction, in the vertical direction, is going to be at 0. And then to the side of that, since these are both 2's, I'm going to have a point in each direction 2 steps away. And so that would be a quick way I can sketch my graph. there's my kind of my sharp point there. Oops, swung wide. I'm telling you, drawing these is tricky, even for people who have done it before. So you can kind of sketch them that way. If we were going to have, let's say, 3 minus 3 cosine theta, then the negative 3 would mean that my furthest point away is going to be to the left, and it's going to be 3 plus 3. It's going to be 6 units away. And then that's my furthest one away going to the left, so I'm not going to have any points going to the right. And then because these are both 3's, I'm going to have one dot that's up 3 points and one dot that's down 3 points. And then that would be the 4 points I need. So plugging in the coordinates is the safest way to go, but there are some ways you can kind of finagle. Oh, finger slipped. There are some ways you can kind of finagle the coordinates and get them that way, or at least use that to check your graphs. And you'll get graph paper. You won't have to freehand them like I did here. But hopefully that helps you set up for cardioid graphing.